Hello everyone, welcome back to another GIS Mathematics lecture video. And in this lecture video, I want to go through one last example of matrix multiplication. And I want to go through one that isn't these even 2 by 2 or 3 by 3 matrices. So you can see what happens when when the dimensions are actually different. So let's go ahead and look at this example right here. A is now a 2 row by 3 column matrix, and B is a 2 by 2 matrix. And so let's ask ourselves, what is A times B? Well, before we do that, let's think. We have a 2 by 3 matrix, and we want to multiply that by a 2 by 2 matrix. So as always, the first thing you do is check the inner dimensions. Do the inner dimensions match? Well, in this case, does 3 equal 2? The answer is no. So you actually can't do this, right? AB is not defined, right? We don't have a way of doing matrix multiplication when the inner dimensions don't match, okay? But let's look at BA. Is BA possible? Well, let's think here. So for BA, right, our first matrix is a 2 by 2. And we're multiplying it by A, which is a 2 by 3. So again, we check the inner dimensions. Does 2 by 2 match? Yep. So now we check what are the outer dimensions, 2 and 3. So we know that not only does this work, but we know that our resulting matrix is going to be a 2 by 3 matrix. So I'm going to color code. I'm going to do A in red, and I'm going to do B in blue. Okay. So let's take a look at what this means. So let's go ahead over here and rewrite our matrices. I'm going to do B first, just because it's easier to do our matrices in order. So this is going to be B. We know that's 3, 6, 5, -1. And then we have our A matrix, which we know is 2, 3, 4, 9, 8, 7. Okay. So B times A. We know we're going to get a 2 by 3 matrix, so I'm going to give myself plenty of room here. So just like before, we're considering the rows in B times the columns in A. Okay? So the first element is going to be the first row in A, or first row in B, so 3 and 6. Right? So 3 and 6. And 3. You know what? I'm actually going to go ahead and I'm going to remove this brace over here. So we can cap it off at the end. So we know that this is going to also be 3 and 6. We know this is going to be 3 and 6. Right? Because we're going to have 3 columns, 1, 2, and 3. We're going to have 2 rows, 1 and 2. So everything in the first row of our output matrix is going to be based on the first row of B. Second row of the output matrix is going to be based on the second row of B. So this is going to be 5, -1, 5, -1, and 5, -1. Okay. So now let's look at the columns, right? We're going to be based on the column vectors from A. So column 1 is going to be 2 and 9. 2 and 9. The second column is going to be based on the second column from A. So this is going to be 3 and 8, 3 and 8. And then the third column is going to be based on the third column from A. So this is going to be 4 and 7, 4 and 7. And then finally, we can cap this off, put the plus signs in where they belong. All right, I'm going to scroll down just a little bit to give us a little more working space here. So let's go ahead and do the math here, at least the first part of the math. 3 times 2 is 6, plus 6 times 9 is 54. 5 times 2 is 10. Negative 1 times 9 is negative 9. 3 times 3 is 9. Plus 6 times 8 is 36 plus 12 is 48. 5 times 3 is 15. Negative 1 times 8 is negative 8. 3 times 4 is 12. 6 times 7 is going to be 42. 5 times 4 is 20. Negative 1 times 7 is negative 7. So if we reduce this down here, 6 plus 54, that's going to be 60. 10 minus 9, that's going to be 1. 9 plus 48, that's going to be 57. 15 minus 8, that's going to be 7. 12 plus 42, that's going to be 54. And 20 minus 7, that's going to be 15. Hopefully I did the arithmetic right in those additions, but you get the idea of where this is coming from. So again, right, it's the row vectors of whatever the first matrix C is times the column vectors of whatever the second matrix C is. So hopefully this makes sense, and if you have any questions, please reach out. Thank you.